Our atmosphere is a delicate shield. It protects us from the harshness of space. At its edge lies the thermosphere. This layer, hundreds of miles above us, is home to a growing crisis. Thousands of satellites orbit within it, connecting our world. These satellites are vital to our modern world. They facilitate communication, navigation, and scientific observation. But their orbits are increasingly threatened by a problem largely of our own making: space junk. This debris, remnants of past missions, poses a significant danger to active satellites, and the problem is growing worse. The culprit, the very greenhouse gases warming our planet, are also causing the thermosphere to shrink, setting off a chain reaction with potentially catastrophic consequences. Greenhouse gases, like carbon dioxide, trap heat within our atmosphere. This warming effect is most pronounced at Earth's surface, leading to rising global temperatures and climate change. However, these gases also have a profound impact on the upper atmosphere. As greenhouse gas concentrations increase, the thermosphere cools and contracts. This contraction has a direct impact on satellites orbiting within this layer. Normally, satellites experience a slight drag from the thin atmosphere at these altitudes. This drag helps to gradually lower their orbits, eventually causing them to burn up upon re-entry into Earth's atmosphere. However, as the thermosphere shrinks, the atmospheric density at these altitudes decreases. This reduced density leads to less drag on satellites, causing them to remain in orbit for much longer periods. While this might seem like a positive side effect, it exacerbates the problem of space junk. Space junk encompasses a wide range of objects, from defunct satellites to spent rocket stages and even fragments of previous collisions. Every piece, no matter how small, poses a threat to operational satellites. Even a tiny piece of debris traveling at thousands of miles per hour can cause significant damage upon impact. A collision with a large piece of debris could destroy a satellite, creating thousands of new pieces of space junk in the process. This cascade effect, known as the Kessler syndrome, could render entire orbital regions unusable. The shrinking thermosphere is exacerbating this problem. With less drag, space junk lingers in orbit for longer periods, increasing the density of debris and the likelihood of collisions. This creates a dangerous feedback loop. More debris leads to more collisions, generating even more debris. Section 4. The sky is falling, a crisis in slow motion. The situation is more dire than many realize. A recent study by MIT researchers highlights the urgency of the problem. Their simulations show that if greenhouse gas emissions continue at current rates, the carrying capacity of low Earth orbit could shrink by 50 to 66% by the end of the century. This means that LEO, the region where most satellites operate, could become significantly more crowded and dangerous in the coming decades. As Richard Linares, one of the MIT researchers, warns, our behavior with greenhouse gases over the past 100 years is having an effect on how we operate satellites over the next 100 years. The implications are profound. Satellites are essential to our modern way of life. They provide vital services, including communication, navigation, weather forecasting, and Earth observation. The increasing risk of collisions threatens the sustainability of these services, with potentially severe consequences for our interconnected world. Section 5. A future adrift navigating the debris field. Imagine a future where the night sky, once a tapestry of stars, is obscured by a swarm of debris. This isn't science fiction, it's a potential reality if we fail to address the growing problem of space junk. The consequences of inaction are significant. Collisions could disrupt vital satellite services, impacting communication, navigation, and financial transactions. Scientific missions, including Earth observation and astronomy, would face increased risks, hindering our understanding of our planet and the universe. Moreover, the increasing density of debris in low Earth orbit could create a barrier to future space exploration. launching and operating spacecraft would become increasingly difficult and dangerous, potentially limiting our ability to explore beyond Earth. Section 6. Safeguarding our future in space. The situation is urgent, but not insurmountable. We have the power to mitigate the risks and ensure the long-term sustainability of space activities. The first step is to acknowledge the problem and its connection to our actions here on Earth. Reducing greenhouse gas emissions is crucial, not only for the health of our planet, but also for the future of space exploration. By addressing climate change, we can slow the thermosphere's contraction and reduce the long-term risks posed by space junk. In addition, we need to develop and implement responsible space practices. This includes designing satellites for easier disposal at the end of their operational life, actively removing existing debris from orbit, and investing in technologies to track and avoid collisions. The future of space exploration depends on our actions today. By recognizing the interconnectedness of our planet and the space environment, we can chart a course towards a sustainable and prosperous future among the stars.